So today we're looking at kinematics. And the first question is, we want to be able to locate objects using distance. But as you can see with the example of a cup, there might not be one right answer for a question like this. So the first question is, where exactly is my cup? Using a measure of distance like meters or kilometers. I think the answer that I wrote was, it is 75 centimeters above the floor of this classroom. Are there any other answers in the class?
I said 3 meters away from me.
3 meters away from me. 2 meters away from Sujin. There's many possible ways to locate the cup in the classroom. I could also say my cup is 2 meters from the door. Okay, so to indicate the position of an object, I need, first of all, a quantity of length or distance in units, and then I also need where I'm measuring that distance from. And the point that I'm measuring from is called my reference point. And probably a lot of you guys use yourself as a reference point. The cup is 3 meters away from me. So even by choosing a different reference point, the cup itself doesn't move, but the measurement changes. So it might be 2 meters away from one person in the class, but 5 meters away from somebody else. So the measurement changes based on the reference point. Now the measurement we made in blank number 1 is called the position. Now the position can be a positive or a negative number, because position has direction. Usually we think of an object's position along a certain direction. For example, the x-axis or the y-axis. We could say from somewhere from north to south, east to west, left or right. So we usually have north being positive and south being negative. East being positive and west being negative. Right being positive, left being negative. So you can have a positive or a negative position. Okay, 1 meter to the right would be 1 meter in the positive direction. 1 meter to the left would be 1 meter in the negative direction. So I can have positive and negative distances. Now in the picture below, there's 3 objects on a road. And you can imagine an imaginary number line between those objects. And those distances are being measured in meters. Now wherever you place 0, that's also known as the origin or the reference point. Okay, so my reference is at 0. And all the other distances are how far away I am, in this example, from the lady. So you might want to ask, if I want to know the position of the car, how far is the car away from the woman?
Where on the car?
That's right, where on the car? Is it 10 meters away from the woman or 15 meters away from the woman? Okay, now when you're doing physics, you're always going to measure from the center of an object. So if you want to place the position of the woman, you would say that she is right there, and the car is right here, right in the center. So usually in physics we draw a dot to represent the center of an object, and that's the point that we measure to. So let's see, where exactly is that car? The center of the car is approximately negative 12.5 meters. The woman is right at 0. And the ball, again, we're looking at the center of the ball to find the position. It's at 17. Okay, and the positive 17 means that it's to the right, and the negative means that it's to the left. Now position has two measurements. Position measures both the size and the direction. Okay, and another word for size, especially in physics, is magnitude. Now, if an object or a quantity has both magnitude and direction, it is called a vector. One of the important words from physics. Vector. Okay, what's special about a vector is that it has size and direction. So some examples of vectors are position, velocity, acceleration, force, impulse, and momentum. Vectors can always be recognized because they have a small arrow above the variable. And the arrow is indicating that there's some direction involved with that quantity. And there's a couple ways that you can write that arrow. You can write it directly as an arrow, or you can write it with an arrow kind of like this. And that's what I do. So the force is a vector, so I would put a little arrow above it like that. Acceleration, I would write with an arrow like that. Okay, and that just means that I'm measuring not only the size, but also the direction. Are there any questions? Okay, on the second page, the other type of quantity that you have has only size. And those are called scalars. The important idea number 2. Some examples of scalars are like time. Okay, we don't talk about the difference between 3 seconds forwards and 3 seconds backwards. Maybe one day time will be a vector when we can go back in time. But for now, time's a scalar, moving only forwards. Mass, you don't have like positive 5 kilograms and negative 5 kilograms. It's just 5 kilograms. Distance is an interesting one because there's distance and there's position. And so those are similar things. One has direction, one doesn't. Same thing with speed. There's speed and then there's velocity. So these are two similar quantities, but one has direction and one doesn't. Temperature doesn't have any direction. We don't care what direction we are in 21 degrees Celsius, even though you do have negative numbers. And energy is another scalar quantity. So today we're going to be looking at distance and position. So distance is just the length between two objects, and it doesn't matter which direction you're measuring. So the distance from the rabbit to the house is the same as the distance from the house to the rabbit. It doesn't matter whether you're going to the left or going to the right for distance. So let's see. The distance from the rabbit to the cow is from negative 14 to positive 13. The number of spaces is 27 meters. And from the cow to the house is sitting here at 5. So from 5 to 13 is 8 meters. Okay, so some of the key vocabulary that we're using in this unit is right there, and I'll get you to define that on the very last page. But now we'll do some practice questions. So you've got a map, and on the following page are some questions related to the map. So we're going to start by assuming that the alley in High Street is the reference point. So you're going to assume that this point right here, right at the corner of Alley and High Street, is your reference. So measuring from there, we're going to determine how far is it to the northwest corner of the co-op? Now I need my never eat soggy wieners. Northwest would be this side over here. So the northwest corner of the co-op would be this corner of the co-op. So now I'm going to just take my ruler and measure how far is it directly from here to here. I've got some extra rulers for you guys for doing those measurements. I think it's like 3 centimeters. .1 centimeters. You can be as precise as you can, depending on whether you want to use 1 sig fig or 2 sig figs. I'll just use 1 sig fig. 3 centimeters. So on this map, 1 centimeter equals 3 meters. So 3 centimeters would be the same as 9 meters. I just multiply it by 3 to find out how many meters it is. So 3 centimeters times 3 would give me 9 meters. That's me. Interesting. Okay, so you can use a ruler to calculate the following distances. And answer the questions on both pages 3 and 4.